Today we're going to review inequalities, and up here right now what we have is the definition of inequality, and I'll let you look at that. I want to look at some other more important things for us that can probably help. And when we graph an inequality, as you can see on some of our examples here, we're going to be graphing these inequalities, and we need to know some of the notation about that. And when we have this symbol greater than or less than, what we're going to do is we're going to use an open dot. And when we have an equals in the problem, as the next part is, use this kind of dot when we have greater than or equal to or less than or equal to. That's going to be a closed or filled in dot. And before I get going too much farther, what I've learned is that some people don't know that this symbol means greater than. So if you need to, write that down on your paper. You're going to have to squeeze it in somewhere. You can maybe squeeze it in at the top, which means this is less than. What I like to say is that less than points to the left, and then this symbol therefore is greater than or equal to. That line underneath is equal to. And pointing to the left again, then is the less than or equal to. Just in case you need that. Some people do. The other thing that we're going to focus in on today is interval notation. And this may be brand new for you, but with interval notation, what happens is when we have the greater than or the less than symbol, we will use parentheses. And if there's an equals in the problem, greater than or equal to, less than or equal to, when we're putting this in interval notation, we use a bracket. So I hope that when we work on these, that it's not going to be quite as bad as you might think it is. The first thing that we need to decide is, are we going to have a filled in circle, or are we going to have a open circle on the 4? We're going to have filled in. It's greater than or equal to. So we're going to go to 4 on our number line here, and we're going to put a filled in dot. We want values that are greater than 4. So we're going to go this direction here. And try to darken it in enough so that your teacher can read it. So if you're using pencil, you're probably going to have to darken a little bit more than if you're using pen. Just make sure that your teacher can read that. And then when we deal with interval notation here, sometimes it looks kind of like an ordered pair. But what happens is, we started our graph at 4. And because there's an equal to, it says x is greater than or equal to. Because there's an equal to, we're going to put a bracket in there. And what's happening is that our number line is going to keep going towards Central Avenue. And then it's going to cross over Central Avenue, and it's going to keep going forever and ever. Which means that it's going to go to infinity. And not my best infinity symbol. Sideways 8, if you prefer. And that's our interval notation for this inequality. And again, that might be the first time that you've ever seen it. We're going to go through our examples here with this interval notation, and we'll just start getting a little bit of practice on it today. So as we look at problem number 2, x is less than 5. We're going to go to 5 on our number line here. Are we going to have an open dot or a closed dot on 5. Open. There's no equals there. Again, this means x is less than 5. So we're going where the numbers are smaller than 5. I'm not going to fill in the entire number line. That's usually what I do. Just getting us going enough in a direction that we know which way we're going. This graph is going to go towards the fairgrounds, and it's going to go right through the fairgrounds, and it's going to keep on going. And what we do when we're writing interval notation is we go in numerical order. So where is this number line going? It's going to negative infinity. The smallest possible number that we can come up with, but it's so small that we can't even put a number to it. And I forgot to say in that last problem that infinity or negative infinity always has a parenthesis sign. Every single time. Infinity or negative infinity always has a parenthesis sign. If it has an equal to, it's going to have a bracket, but not for infinity. Regardless of what it is, infinity is always a parenthesis. Pepper? I wanted a parenthesis with the infinity. That's the only one that needs the infinity. The 4 gets the bracket because it's got the equal. Does that help? So when we look at this next one here, we've got negative infinity. It's going to go from negative infinity to 5, but because 5 is an open circle, or because this is just less than, it also is going to have a parenthesis. There's no equal, so we get a parenthesis. Number 3. Maybe a little bit harder because it's written in a little bit different format. I told you I've taught college algebra for many years, and we do a lot of inequalities in college algebra, and I have come up, and it's not even new, with the saying, letter on the left. I prefer, personally, it's not that I can't do the problem like this, but I prefer to have the letter on the left, and you might like it as well. So to convert this to the letter on the left, let's write the x on the left, which is going to put the negative 4 over here on the right. But our inequality symbol, that pointy thing in there, is pointing towards the negative 4. So when we rewrite this, it still needs to be pointing toward the negative 4. Once we get it written in this format, I think that it's a little bit easier to read. Because this says negative 4 is less than x, and this says x is greater than negative 4. When we graph it, we're going to put an open circle on the negative 4, and we're going to go to the values that are bigger. But again, the best way to do that is to write the letter on the left. When we put our interval notation, well, we're starting at negative 5. There is no equals in here, so we're going to have a parenthesis. And again, we're going to keep going towards Central Avenue, and then we're going to go right across it. We're going to keep going on and on and on and on. So we're going to keep going. Negative 4, thank you. I wrote negative 5. I don't know if I said it right or not. Negative 4 to infinity. Thank you for correcting me. So as we look at example number 4, 6 is greater than or equal to x. Let's put our letter on the left so that it's x is, and the 6, letter on the left, move the 6 over here to the right. We're pointing towards the x, so we still need to point towards the x. And personally, I think that that makes it a little bit easier for us to graph. Are we going to have a open circle or a closed circle on 6? Closed circle. Are we going to draw our line to the right or to the left? Because we're going left there. Then make your graph dark enough so the teacher can read it. And when we write this in interval notation, what happens is we're going from the smallest value in this number set to the biggest value, which is 6. I almost wrote 5 again. To 6. Infinity always has a parentheses. Whether it's positive or negative, it always has a parentheses. There's an equals in this problem, so our number gets the bracket there. We can mix them up. We can have parentheses and a bracket. We don't have to have both of the same. So, there on the first 4 problems, what we're doing is we were drawing the number line and putting in interval notation. Now we're going to go the other direction. We're going to be given the picture, and we want to come up with the inequality. So, let's start with putting our letter on the left. And as we look at this, we see a solid dot on 5, which means that we have an equal to in the problem. And our arrow is going towards the left, which means that we've got less than or equal to. Equal to, once again, because the dot on our graph at 5 is a solid dot. In contrast, when we look at example number 2 here, we've got an open dot on this one. Still going to start with my letter on the left. Our shaded in area is to the right, but because it's an open or a not filled in circle, it's going to be greater than -1. So I'm missing the next little statement. I don't know where it went on my smartboard, but sometimes we can put 2 or more inequalities together and ask what x values make both of them true. If they're both true, it's called an AND problem. And if we look at which makes either or the other true, it's called an OR. When we look at this here, what this problem means, and again, I think you can fit it in if you want to write out the words here. What this inequality means is we have more than one, first of all. It means that x is between -3 and 5. We don't know what it is, but somewhere between -3 and 5 is our value of x. And it's combined here. -3 is less than or equal to x is less than or equal to 5. This is an AND problem. AND does not have to be written. But if we know what it means, then it's fairly easy to graph. And luckily on this first example here, -3 is less than or equal to. Well, here's 0. 1, 2, -3. Filled in. I wanted to put an open circle there, but equals means that we have a filled in. And then over here is 5, there's an equal to. X is less than or equal to 5. And our value is somewhere in between there. Somewhere in between. Now, for interval notation, when we write this, we've got equals for both. Start with the smallest value. -3 is smaller then 5. And since both of those values have an equal beside it, we're going to put a bracket on both. No infinity on this one. You're limited on this one because we have a starting point and we have an ending point. So as we look at 6, remember there's and or there's or. So this next one here is an or. And or must be written. So that makes the ors maybe a little bit easier. X is greater than 4. No, equal to. So we're going to have an open circle. Greater. Bigger. Go in that direction. Or x is less than or equal to negative 1. Less than or equal to. Again, I wanted to do the same thing. It's got an equal to, so we have to fill it in. Less than. We need smaller values, so our less than values are going to go towards the left. And there's our or. For the interval notation, let's still write it in numerical order. This part of the graph is negative infinity to negative 1, because it keeps going forever and ever. Infinity always has a parentheses. The negative 1 has an equal, so we're going to put a bracket. But the answers are either in this part of the graph, or they're in this part of the graph, so we need to put these together, and the symbol that we use is a U. It stands for union, which means joins together, and we can finish our interval notation over here with 4. 4 does not have an equal sign, so it's going to be a parenthesis. And it's going to continue on forever towards the right. So it's going to be 4 to infinity. Infinity always has a parenthesis sign. Positive or negative. It always has a parenthesis. Yes, a parenthesis. So I'm going to skip 7 and 8 now. I'm running out of time. And I want to go down and look at the last 2. And maybe we can come back. But for each of the following graphs, we want to write a compound inequality that describes all the numbers shown graph. Oh, my directions aren't very good. But the compound inequality here. What we've got is we've got an arrow going one way and an arrow going the other way. Is that an and or an or problem? It's an or. So let's write or. We have to write the word or, and then we can fill in the rest. Here our open circle is at negative 4. This is going to be x is less than negative 4. No equals because it is an open circle. And over here, our filled in solid dot is at 3. So it's going to be x is greater than or equal to, because it's filled in, 3. Ors look like it looks like 2 rays going in opposite directions. One going one way, the other going the other. On the next one, it looks like an and. We have a starting point, we have a finishing point on here. And we don't have to write and. Remember, what we're looking for is the fact that x is in between 2 values. Well, it's in between 1 to negative 3. And over here, 1, 2. I'm going to put that there. They're both open circles, so that means that we're going to not have any equals in there. And what happens is all of our values are going to be smaller than 2. And they're going to be bigger than -3. So our inequalities are going to point in the same direction. But let me jump up here and finish. Should we do one more and or one more or? Morgan?
Well, the inequality is always going in the same direction.
Yes. But, and Morgan, they really should point that direction. There's it's going to go that way. So let me turn off the recorder here, and we'll stop those notes if I can.